Okay, so this first one that we're going to do is the box top. Okay, box top, what you'll notice is that all of these are done in millimeters. So we're going to start by opening a new part. Okay, we're going to create a standard millimeter part. So we've got our workspace open. Okay, how we're going to do this box top is we're going to first start with a solid piece, and then we're going to hollow out that inside part as you see that it is in the drawing that you have there. So we're going to start by creating our 2D sketch. I'm going to create the 2D sketch on this level plane here. I'm going to start with a rectangle, 2-point rectangle. I'm going to drag it out. And just to make the modeling easier, I'm going to constrain that so that the origin of my plane is in the middle of my rectangle. We know how to do that. I'm going to do a vertical constraint between this midpoint and the origin, and I'm going to do a horizontal constraint between this midpoint and the origin. So now it's centered. Okay? And you need to add dimensions. What does it look like the dimension of the long side is based on the drawing? Looks like it's 50 millimeters. So we're going to enter 50 here. The dimension on the short side looks like it's... Yep, looks like it's 20. There we go. Okay, so we have our 50 by 20 rectangle here. And it is fully constrained now. Everything is in purple. The dimensions are locked in, plus the location of the shape is locked in. So everything is fully constrained. I'm going to finish my sketch now. So I've got this rectangle to deal with. The next step of this rectangle is to extrude it, so we can turn it into a three-dimensional solid. So I'm going to extrude this rectangle. What does it look like the height of that box top is? Looks like it's 15, is that right? Yeah. So I'm going to change this dimension to a 15. Okay. And I am going to extrude it from that plane. I know the other options are to do mid-plane or to have it extruded down. Since it's a topper, I'm going to have it, a box top, I'm going to have it extrude up away a specific distance of 15, and I'm going to click OK. So what you'll notice is I didn't try to create this box top already hollowed out and carved out, so on and so forth. Okay, I just created a block, and now from this block I'm going to carve everything out that I don't need and add all the rounds. Notice that all the edges of this box, at least the outside and the inside, are all rounded. I didn't try to build the rounds into my drawing. I created a box which I'm then going to carve out and then use my fillet feature here to get the rounds that I want. Okay? So I've got the box with the correct dimensions that I want. Now the next thing that we want to do is we want to hollow this box out, because if you look at the drawing, you'll notice that the inside of that box, based on the dashed lines, is hollowed out. And what you also want to notice here, okay, is that well, actually looks like that dimension is missing. You'll notice that the dimension is on the box bottom. It was accidentally left off the box top. If you look at the box bottom, right up here, that's the top one, notice how it says 2.00 TYP. That means typical. And underneath it, it says wall thickness. So the wall thickness on the top and bottom piece of the box is all supposed to be 2 millimeters thick. Okay, so 2 millimeter thick. What's really nice is that Inventor has this command called shell. So we have this command called shell right here. I'm going to select shell. What it does is it goes and looks at the solid object that you have currently in your build window. And it takes and hollows out that solid object and leaves a thickness of what's specified right here. Now right now it's leaving a thickness of 1. What do we want? 2. We want a thickness of 2 millimeters. So I'm going to change that to a 2, but then also you have this opportunity right here to remove faces, because right now the inside of this box is hollowed out. But if you look at the drawing, isn't one of the faces open to that? So what I'm going to do is I'm going to click on this bottom face, which is supposed to be open. Everything is shelled out, and this bottom face is open. So remove face, I'm going to click on this bottom face, and it's going to remove that face. So everything is shelled out, and that bottom face is open. I'm going to click OK, and as we spin this around, you'll see a little bit better that it shelled it out, left a wall thickness of 2 millimeters, and it removed that bottom face. Good? Okay, so we're getting fairly close to our final product, aren't we? Okay, but what else do you notice from the drawing? It's filleted. Filleted, yeah. Fillets are rounds, chamfers are the hard cuts, right? Yeah. Notice right here how it has one of the fillets labeled as a radius R2.00. What's next to that? What is the three-letter acronym next to it? Not an acronym, but an abbreviation. TIP. TIP means typical. It means that all of the fillets on here are what in radius? 2 millimeter fillets. Typical means everywhere you see it, that's the dimension. Rather than having to dimension every single fillet, that would be crazy to have to dimension every fillet on every single edge. Rather, dimension one of them, write tip after it, so that they know that all of the fillets are 2 millimeter fillets. Okay, so we're going to go to our fillet command here. And in the past, we've seen fillet command, and notice, oh great, it's already set to 2 millimeters. That's what we want. If I wanted to change that, I could type in a 3 there, but I want a 2 there. Okay. Now, select mode, I have edge selected, which means I can go out and select all the edges that I want filleted. Watch this though. I can also select loops. Okay. What the loop does is this. I can put my cursor on one of the edges of the top, and it'll select that entire loop up top, rather than me having to select each one separately. It just saves a little bit of time. So I'm going to select that. Notice how it filleted the entire top. But now I probably need to go to Edge and select each of the 4 edges that I've got here, here, and here that I need filleted as well. I'm going to loop it around here, select that edge. That edge right there as well. Okay, but you'll notice in the drawing, okay, that the inside of the box, everything in there is also filleted. Okay, so what I'm going to do is I'm going to tip my box so that I can see the inside. Now watch this, this is really cool. You can not only just select edges or loops, you can select a feature. If I select feature, and I come in here, notice that you have all of these solid lines here. So right now, it's highlighting the entire inside of the box. But it's fairly intuitive. Notice how it's highlighted all of the edges of the box, but notice these 4 edges are dashed, right? It means that it's selecting that feature, but it won't fillet those edges. Because we don't want those edges filleted, because that's the flat surface that mates with the other half of the box. Okay, so this saves us time. We can select the entire feature to fillet. Yes?
What would happen if you selected feature for the outside of the box?
Yeah, so if I selected feature for the outside of the box, it depends. Sometimes it will select only what I want. When I originally made this model, it was also selecting this edge here, and I didn't want that. So I had to improvise, and I did the loop up top and then the edges, but the feature worked on the bottom, which was really nice. So now I have all 16 edges that I want filleted selected. I'm going to hit apply, and look at that. We've got a nice box top here with all the edges filleted that we want. Nice smooth edges there. Great. Okay. Spectacular. Good deal. Okay, so What we now want to do is this. Okay, what we now want to do is this. We have a couple more features that we need